Alright, for question 66, the directions say the given function is not one-to-one, restrict its domain so the resulting function is one-to-one. Find the inverse of the function with the restricted domain, and there is more than one correct answer, so I'll just do one particular correct answer. So in this case, it says that we need to restrict its domain so the resulting function is one-to-one. Right now, the domain is all real numbers. However, if you look here, just given its nature, in this graph being a parabola, the horizontal line test would tell us that this is not one-to-one. So in order for the horizontal line test to pass, what we need is we need to get rid of this, or we need to get rid of this. So I'll do the second. So in this case, what we need the domain to be is all values of x that are greater than or equal to 1. If that's the domain, the range then is y is greater than or equal to 0. So when we find the inverse, because we're switching x and y, we're also going to switch these domains. So in order to find the inverse, we would say x equals the quantity y minus 1 squared. Okay, we would take the square root. When we take the square root, we get the square root of x equals y minus 1. And then here, we would have to add 1. So we have the square root of x plus 1 equals y. So then that would be the inverse of the original function. Now again, the reason it's not plus or minus is because then our domain would not be restricted the way that it should. Now again, the domain here is going to be x is greater than or equal to 0 and y is greater than or equal to 1. Because like all the other x and y values, the domain and range has to flip. Let's graph that just to be sure. Y equals the square root of x plus 1. And let's graph the line y equals x to make sure it's a reflection over that line. And in fact it is. Now again, remember, you're only reflecting the part of this function where x is greater than or equal to 1, because we were making this function, restricting the domain so that this function was one-to-one. And that's one possible correct answer for question 66.